there goes that music again. It's me, John Park. Look, it's here. We are back together, and it is time for JP's product pick of the week. Thanks everyone for stopping by. I'm all amped up because I was laughing at this Spider-Man GIF that Yanisku7 posted there of the strain. It'll all make sense. I'm sure it already makes sense to you, but I hope. That's pretty bold of me to say. I'm sure it makes sense. It's entertaining to me, at least. So, look, what are we doing here? We've got a product pick. We've got a brand new product pick. It's a pretty new product in the store. First time I'm playing with this particular breakout. And if you want to get a jump start on things, what you can do is head to that URL right there, or that QR code. That'll take you to the product page. And in the product page, you will find two key things. One, this show is actually being broadcast from right within the page. And two, the product has been slashed in half, price-wise. Not physically, but just the price. The price is half off. And you don't need a coupon code. You don't need to solve any riddles. You don't need to make up a secret password. You don't need any of that. All you need to do is throw it in your cart. It's already half off. And you can get up to 10 of them, no resellers allowed. And that price will last at that half price until the end of the show, or a little bit after, and then it goes back up. Big, huge thanks to Travis and Jelly and the new products team for making all that happen. So we've got that for you. You can go there, you can go check it out, get a jump start on things. But as is custom here, before I say any more, let on too much, what I like to do is show you the new products video when Lamore first brought this out. So take it away, Lady Ada.
Ta-da! The HX711 load cell amplifier for load cell, strain gauges, and other fine Wheatstone bridge type devices. We stock a I2C version of this kind of sensor, not the exact same one, called the NAU7802. I kind of prefer it because I like I2C, but there's a lot of people who are like, well, I want to connect or log them together. We'll show them in a second. Yeah, they want to connect a bunch together, and they want to use 2 data pins, because then you can have as many. You don't have to worry about sharing the bus and the addresses. Maybe they already have code for the HX711. I don't know. It was a common request from people. So you're going to break out. This is based on the SparkFun HX711. They made an open source version of Breakout Board, and we looked at it and took what we thought was awesome and then added some different stuff that we thought was awesome. So what's nice about this breakout is it has both the A and B channel exported out on the terminal block. So you can connect two Wheatstone bridges. You share the E minus and E plus exciter pins, but then you have two different bridges. The A bridge has 30, I think 64 or 128 gain, and the B bridge has a fixed 32 gain. There's separate power pins for the VIO is the interface voltage, and VIN is like the excitation voltage. So if you have a quieter supply versus your GPIO logic level, you might want to have those separated. Clock and data, it's not SPI, it's SPI-ish, but it's not SPI. Thankfully, the pin runs, the chip runs on 3 volt or 5 volt IO, and so you don't need a level shifter, because again, it's like a bidirectional system. And then the rate select, so you can select either 80 samples per second or 10 samples per second. So let's go to the overhead. I can show a quick demo. So this is, I've got my ESP32 S2 TFT. I got wired up. What's nice is you only need power and then the 2 data pins, and then I have a strain gauge, and then even as I pick it up, it starts to, the value starts changing. So one thing you'll notice is that it's updating really fast because I have it selected for high. If you want more precise, you can set for low. It's only 10 samples per second, but that's still like pretty fast. And then as I twist and bend this, it's going to show like the value changing. So like, it's a 1 kilogram. So as I provide enough force to, torque it as much as like a 1 kilogram weight would, you'll see it goes negative if I push, and positive if I pull. And that's the A channel. Again, there's a B channel as well, if you like. Seems to work pretty well. We've got Arduino and CircuitPython code ready to go. And it's almost fully assembled. You get the terminal block on it. So you just need headers or wires if you'd like. And you're ready to measure. It's a very popular strain gauge or load cell amplifier. Seems to work quite well.
Yes, that's right. That is my product pick of the week this week. It is the HX711 24-bit ADC for bridge and strain sensors. So as you've seen, this is really popular for making little scales using this kind of a little strain gauge Wheatstone bridge sensor. You can see there's one right there. And the way these work is that we need to give it essentially power, so plus and minus on the E pins, the exciter pins. And then we have two leads that we're reading the resistance of as those resistance values change when the material's deflected here, either up or down. This creates a really, really tiny little bit of resistance, which is translated into a super minuscule change in voltage. This is an amplifier. This is a precision 24-bit amplifier that takes those tiny, tiny little voltages and actually makes them readable and useful for creating scales and other types of deflection, strain types of gauges. If you're moving a thing, pulling a thing, squishing a thing, and you want to know about it, this may be the sensor for you. Now, this breakout, unlike the other one that we typically sell, which is the NAU 7802, this one is not I2C, so that's actually one kind of nice benefit depending on your application, because this is an SPI-like interface with two data lines. You can just run a bunch of these. You don't have to worry about the fact that that other one is I2C and on a fixed address, so then you might need a multiplexer for I2C, but you don't have different addresses to use. So this one has that one benefit. It gives us two channels instead of just one. So I think that other chip may have two channels, but they're not broken out on the breakout. This one, they are. So you can read two gauges on just one device. Bear in mind, those will be at different amplification gain levels. This one has the A channel at 64 and 128x selectable, and fixed on channel B at 32. You can also go anywhere from, or I should say, you can go between a 10 samples per second and I think it's an 80 samples per second on a flip of a switch there. Yeah, 10 or 80. And you can use this in Arduino. You can use this in CircuitPython. We have libraries for both. Now, keep in mind, this is going to just return raw values, so you want to convert those into something. I have an example here that I'll show you in a second, but let's first take a look at the product page and the Learn Guide. So there you can see is our product page, and the price right now, $4.98 for one of these sensors. You don't need a coupon code, just throw it in your cart, you'll get it for that price. And you may want to pick up a strain gauge load cell. Depending on your needs, you can get them in the 1 kilogram, 10, 20, and 5 kilogram varieties. They look the same. This one's a 10. The one I have attached there is a 1. It's just a marking on there that you can see, and usually there's a little sticker on the end that shows you the direction that the positive load is measured at. If you scroll down on here, you'll see a couple of paragraphs, info on there. We've got our live stream happening in there and some of the specifications here that I've mentioned. You can then click on this link here for the primary guide that Liz put together. So here you can see we've got the overview info. We have the pinouts, so that shows you we've got V-in or the V-out that's based on the onboard power regulator, supply regulator, and then ground. And then we've got the terminal block pins, which give us the 2 pins you need for the A channel, the 2 pins you need for the B channel, and then the power and ground on E there that you'll supply from your microcontroller, or it could be an external supply depending on the noise level of your microcontroller's 3 or 5 volt out. And then you can see on the pins that are broken out for, or the pads that are broken out for your header pins that you'll solder in and stick in a breadboard or a permaproto, or you could solder directly to it if you want. Those are your power pins that we mentioned up there, as well as these SPI-like serial clock, serial data, and rate control. And then there's a rate select switch. I have it set up, I'm not using the rate pins at all, just the power ground and the 2 data pin or clock and data pins there. And if we take a look at the next couple of links here, you can see we've got a setup here for using it with CircuitPython, and it also shows you how to wire that up. It's pretty typical that you get the black and red wires for power on these, and the white and green are the 2 resistors that are being measured. And then it shows you how to get the HX711 library set up and some example code, as well as Arduino, similar sort of thing. Shows you how to wire that up and use the Arduino library to use that. And then we've got under the downloads section the data sheet on the chip there. If you click on that, you'll see they're in their own words designed for weigh scales and industrial control applications to interface directly with a bridge sensor. So there are a bunch of different types of sensors that use this Wheatstone bridge arrangement. So depending on what you need, check the stats on it and see you may be able to use it with this chip. Now, if we take a look at my downshooter here, let's just look at this view of it for a second. So what I've got set up, the little load cells that we sell, these are kind of nice. They have 2 M5 thread tapped threads on one side, and that's where you'll bolt that down to your surface of your device that you're using as a scale in this case. And then the other side is tapped for M4, and you can set a little plate on there like I've done here, you can see, to give you a little surface to set an object down. This is if you're making a scale-like thing with it. So I've got that just on some 8020 aluminum, T-slot aluminum here, and a little acrylic base here to set my objects that I'm weighing. And then on the little breadboard here, I have a Feather RP2040, and you can see I'm just running 4 pins to it. So remember, this is not I2C, this is this SPI-like interface, and I'm sending power and ground to the VN and ground, and then I'm using 2 pins, I think it's D5 and D6 here, to go to the clock and data pins that are on the HX711 breakout. Then I've got my sensor wired up to the terminals, and there's 2 pins that are not used there, so I could plug in a second sensor if I needed to. And then I've got a couple of sockets here that I want to weigh, so let's take a look right here at the code that I've got running. So you can see, let me pull up that code window. In the REPL here, I've got it weighing this right now. Now, I'm not doing any averaging, and this is kind of crude. My little conversion here is just a dead simple conversion. I'm not tearing it other than a little bit manually by hand, and I'm accounting for the weight of the little plate and screw that I have on there to try to get to a 0 starting point. So with any luck, we'll get some more advanced examples, possibly even, cross our fingers, Cedar Grove, who did the really nice library for the NAU 7802. It'd be nice to see some built-in calibration and things like that, little calibration utilities. But this is working pretty well, so you can see here I've got 7/8 socket here weighing in at 55 grams roughly. I could swap that out for this big 1 1/8 socket, and this one is 209-ish grams there. The precision level on this is, I believe, the same as the NAU 7802. It's a 24-bit ADC. It does roughly a similar sample rate. I think this one might be a little faster. And the way this is set up in code here, you can see I've got the HX711 library here that I'm importing, both the device and the analog ins. And then I'm setting up the data pin on D5 and the clock pin on D6. Data pin is an in, clock is out. And then we set up the, instantiate the device there, HX711. And in this case, I'm just using channel A as the analog in, so the data that comes from that at the 128 gain. We could switch that to 64 here. If you use channel B, that's going to be fixed at 32. And then, like I said, I've got a little just, I experimented with values here. This is the raw values that could tear out that little plate that I built onto there. And then in the main loop here, what I do is I'm creating a variable called mass grams by rounding the channel A value minus the value of this plate. And then this formula here is based on some of the NAU 7802 calculations to convert the raw values, which are coming from the sensor, over to grams. And then I'm just printing that here with mass grams. So fairly basic, but the data coming from it's good, and then you can improve upon the code there, hopefully, to get the calculations that you need. Cedar Grove Maker actually mentioned over in the chat, let me pop up the chat actually for a second here, that they're going to try it and a couple of other strain gauge ADCs as a moisture saturation meter. These bridge ADCs are pretty good for milli and microvolt differential signals. Yeah, so there are different things other than the strain gauge or load cell that use that Wheatstone bridge arrangement to measure the strain that a thing is going under. So you can try other things. Thanks, Cedar Grove. And by the way, I should mention, this is our, if you're new here, this is our Discord chat. So if you're looking for the chat and you're not finding it over in Twitch or Facebook or somewhere where we're not keeping an eye on the chat, check out our Discord at adafruit.it/discord. Get an instant invite and head over to the live broadcast chat channel. I am keeping an eye over on the YouTube, so hello to Dave Odessa, Tackle the World, Zach, Zoe Sherry, thank you for stopping by. And yeah, the question was asked there by Zoe Sherry, what are some tutorial ideas besides weight sensing you might create with this? Yeah, with these, I mean, these are essentially the design for that. You could use them for the amount of strain being put on something, so up to however large of a sensor. We sell up to 20 kilogram sensors, but you can use them for things where you need to test how much stress is being put on something. So, you know, potentially you could use this for something like, I don't know, a tennis racket or maybe a pickleball racket would be a better scale of thing, where you install that type of, where'd mine go? That type of sensor between a handle and a business end of a thing, and you'd be able to test the amount of deflection that happens to the material there. But there are other types of flex sensors, pressure sensors even, where a somewhat flexible membrane gets pressed and it has this arrangement of two resistance values that come off of it. All right, let's see, what am I forgetting? So yeah, if you didn't see that before, that's the URL you want to go to if you want to check this out. This is product page right there. It is $4.98 right now, so a nice bargain. And just be sure to pick up one of these, or two even. You can plug two of them in. Load cells of the size that you need, of the weight measurement that you need, or mass measurement that you need. Okay. Rufus, no, Rufus asked the question, did it weigh 0 when you removed it? No, because my methods are kind of crude here. Let me see if you can see it. I've got a little bit of slop in there. I'm not averaging it. I'm probably a little bit noisy on it. This is not the fault of the breakout board. This is just my code that's picking up and probably amplifying those very, very tiny differences there. So there's a bit of slop in there, and then there's some tear amount that I need to get right, probably with calibration and multi-sampling to get that a little better. So hopefully, if you pick this up, you'll be able to improve on the code. This is based on just a real simple example we have that's outputting the raw values. And in fact, if you want to see what those look like, let me, I can just print out the raw values that come off of the sensor, so they look like this, and we can speed that up a bunch. I was just not printing very fast there. For some reason, this one, yeah, so there's my plate value. Let me set that to 0. That's what I was subtracting from there. Oh, is this not saving there? Oh, that is not subtracting that. Okay, yeah, so that is my plate value, right, roughly? Okay, so we can do mass grams minus plate here. That should tear that out, and if I get those numbers right, we should be back to 0. Oops. So I just need to add another 400 to that. C. Grover says, with the right strain gauge and plate, you can also measure airflow and direction. Hey, how about that? Weigh your pets when they eat and change how much you feed them. Yeah, there's a lot of neat scale things. C. Grover worked on, I collaborated with C. Grover on a coffee bean and coffee espresso extraction scale using the other sensor. Oh, that's a good idea. So Cedar Grove said, try blowing on the plate and see if we get a difference in it. So what are we looking at here right now? Max of about 600. Let's see if I can. What did it get up to? Yeah, you definitely can. Hey, how about that? That is pretty sensitive. So yeah, so maybe some sort of airflow measurement, liquid flow measurement. This possibly could be done. Very cool. Oh yeah, Zoe Sherry says, my local makerspace might benefit from a sensor that can tell people when propane tanks are empty. Really popular use of a scale type of project. And you can connect that sort of project into things like Adafruit IO or other MQTT servers and Internet of Things servers so that you can get alerts when things reach a certain level. Same with kegerators. I know that's a popular one for kegerators. What's the temperature rating, says Abbotist. What if I have too much hot air? That could be it. Use it to measure thermal expansion. Yeah, put it under toilet seats to weigh that someone's sitting on them. Absolutely. Okay, good suggestions. Ooh, someone mentioned the Power Glove too. I like it. Okay, I think that's it. We'll wrap that up here. So thanks everyone for stopping by and checking this out. I think we've still, let me double check, I think we've still got them in stock. We had stashed a bunch of them for the show. So if you want to get them in the next 5-10 minutes. The price will be going up after the show. That right there is my product pick of the week. This week it is the HX711 ADC for load cells and strain gauges. For Adafruit Industries, I'm John Park. This has been JP's product pick of the week, and I will see you later. Bye-bye.